program of work was being prepared in schizophrenia by Dr. Peter Little, who had obtained a Wellcome Trust grant to study oxygen metabolism and blood flow in the brains of schizophrenics. And he had defined the three categories, negative and positive categories and some other. And he was hypothesizing different patterns of metabolic profile in the brains of these patients in the steady state. And he was successful in that grant application, and that came with it a funding for a research fellow. And we had two applicants for that position, one of which was a man by the name of Carl Frishton, who appeared in the summer in a long brown camel-hair coat, which is rather interesting. But clearly Peter knew of him and realized he was quite an intellectual force and was very keen, although he didn't come over in any sort of heavy sense at the interview. Carl then systematically and very quickly went about collecting this data, which wasn't trivial because there were 30 schizophrenics. He had to sleep overnight in St. Bernard's Hospital, to really collect them all, and they had to be especially sort of, worked up into these separate categories. He then had the problem of analysing the data and sort of how can you systematically categorize these people and look and observe and search for differences in their neurofunction anatomy. And at that time, the St. Louis group were doing something on statistical mapping of a sort, and I had a paper to referee from the Journal of CBF Metabolism, so I didn't fully understand, but I showed it to Carl, say, what do you think? This is interesting activity. And that may have sparked something in him, I don't know, or maybe he'd already been thinking, because he'd got, as I believe, a quantum mechanics background. He originally did physical sciences, and he's obviously been thinking along those lines. But shortly afterwards, he came up with this concept of statistical parametric imaging mapping. Now, this was quite traumatic. I can't overestimate how much it was, because it was a shock to us at Hammersmith, because we were then, at that point, myself, Vin Cunningham, Adrian and Mertzimer, were very quantitative, which means measuring blood flow to mils per gram per minute. Great detail, that's quantitation. And here was this guy, Friston, sort of riding roughshod over all this and saying, no, I'll take 5 of those and 5 of those and look for statistical differences between the topography. And it was quite a shock, because in a way it's as much quantitative as what we were doing, because he was looking at where were the quantitative statistical differences, where were they quantitatively in Cartesian space. So it was a quantitative statement he was doing, but it wasn't mils per gram per minute. And I think Carl, and the way he is quite flamboyant in his speech, and of course he's eloquent, and there were a number of internal brain meetings which thrashed it all out, and you can imagine the sort of, I wouldn't say culture clash, but I thought it was necessary, it had been necessary to go through that for Carl, so that he have his teeth cut, as it were, on the prejudice world of how we should be analysing data. And I think it strengthened his resolve to go ahead, and I think people accepted what he was doing, because what he was doing was saying, I'm looking for statistical differences. I want to be sure where they are. And I'm not just looking at that region of interest where it may happen, but I'm looking at the whole brain and seeing the statistical variation in the brain. I'm using that whole data set to define what's the jitter in the data. And when I see something over and above that jitter, I know it's significant, because I'm comparing it to a huge body of data. It's taking the data as a whole, rather than up until then, we just look at one region and see if it was working. And that was the power. And the power then, because you're using the whole data, you could pick up quite some subtle differences. And it suddenly occurred to me that if the statistical differences are not in the raw data before you process for blood flow, they'll never be in the data after processing. Those statistical changes have got to be in the fundamental data you record. And then there was a bit of a tussle amongst, again, the culture. People saying, it's got to be quantitative. But no, just use SPM on the raw data. Don't need blood sampling. Just say the radioactivity in the brain, has it changed regionally? If the raw data upon which you calculate blood flow, if that's not changing statistically in the region, therefore you haven't got a signal. And that meant you could then begin to do activation work without taking blood samples. You could then do it much easier, much simpler, and it blossomed the field. You could do things much easier, ethics were less of a problem. Well, quite honestly, we were making hay then. We published 5 Nature papers on this stuff. And you need that sort of, to pay the bills, basically. You need that sort of profile to pay the bills so you can bring on other things underneath, like the more longer term. So we were doing 120 scans a week. That's about, I don't know how many patients that was, about 12 patients or so. We were doing a lot of studies. We brought on a camera more or less specifically for that, the retractable receptor camera. We were able to do studies way into the evening, make very efficient use of the facilities, quite simple studies. I mean, injecting in water, no arterial blood samples, very challenging in terms of data handling, the unit. We were doing 3D reconstructions, really challenging. So we were pushing the system hard, and we were making hay, scientifically.